Now, when dealing with calculus, let's understand the different parts that we have. Now, we can talk about the first one is first principles, right? Derivative from the first principles, and then we have differentiation rules, differentiation rules, and then we have tangents, right? Tangents to a graph, tangent to a graph, right? And then we have graphs themselves, graphical application, and then we have, lastly, you have optimization. So this branch of mathematics, it has a lot of things we need to know, right? But perhaps our story just begins with a gradient. A gradient is when you calculate a gradient, which is y1 over y2 minus y1 over x2 minus x1. This is your gradient. Now the gradient is simply what? The slope of a line is the slope of a line. So I need you to understand that if you are given f of x is equal to something, if you calculate the gradient, understand the answer that you are getting to say what is it. The answer that you get here is an equation to get the gradient of the graph at any x value you substitute. At any x value you wish to substitute. Okay, that is what you get whenever you're getting this. This is called the derivative of the graph. Now that derivative is an equation that you're going to use to get the gradient of the graph at any x value that you wish to substitute. Now to demonstrate that, let's say we have f of x. They say find the derivative, and then you're given f of x. Let's just say it's 2x cubed minus x. Now this is a cubic function. The derivative is going to be, for you to get the derivative, you need to apply the rules. Now the rules are simple. The rule says that if you have any expression in the form of this to the power of n, to get the derivative you're going to say a multiplied by n. You say whatever is the coefficient times the exponent, then you write the variable, then you say n minus 1. You subtract 1 from the exponent. So and then it says if you only have ax and then the exponent is simply 1, then the derivative is simply going to be a. And then if you have a constant, the derivative of a constant is 0. Okay, so here let's say maybe we have plus 6. How can we apply that knowledge to find the derivative? Well, we can say the derivative is going to be 2 multiplied by 3. It's 6. Then you write the letter, guys, and then you say 3 minus 1. It's 2. You saw what I did? 2 multiplied by 3 is 6. Then you write the letter. Then 3 minus 1, you get 2. What about on this part? You have negative 1 here, guys. Even though we don't write it, you must know that is negative 1. The exponent is 1 there. If the exponent is 1, you simply take whatever is the coefficient. So we just take the negative 1 there. And then what about this one? It falls under a constant. How do you know something is a constant? You know that it's a constant if it's something that is not attached to x. You see, all the others are attached to x, ne? They're attached to x. So if it doesn't have x there, it's the derivative. It's just gonna be plus 0. So your derivative is simply going to be 6x squared minus 1. So what did we get here? What is this thing? This is an equation, as you can see, right? But what can we use this equation for? We can use the equation to find the gradient of the graph at any point. Or we can use it to find the gradient of the tangent to the graph at any x value. Okay, that is what is important. You need to understand that the derivative there is simply an equation that you can use to find the gradient at any point. Now let me give you just a rough idea as to how that graph looks like. If we check it, if we were to draw it, it's gonna look something like this. It has a positive here, so it's gonna be maybe something like this. For example, this is gonna be your f of x. Now suppose I draw a tangent here. Suppose I draw a tangent line there. A tangent line is a line that touches the graph at only one point. So as you can see, a tangent line is simply a straight line. A tangent is simply a straight line. And if I want to find the equation of a straight line, what do I use? I use y is equals to mx plus c. Do you remember that if I want the equation of a straight line, I use y is equals to mx plus c? What is m? M is the gradient of your straight line. So in this case, our straight line is a tangent, so it is the gradient of a tangent. Guys, a tangent is nothing special. A tangent is still a straight line, just that we are calling it tangent because it touches the graph at only one point. Tangent touches. So now, the problem would be now, okay, what if I know that here, what if I know that there, let's see. What if I know that what if I know that the point here is 1:7, I know that the point there is 1:7, but then can I use that point to find the equation of the tangent? Let's say the question said find the equation of the tangent. Find the equation of the tangent to f at x is equals to 1. I want the equation of the tangent of tangent to f at x equals to 1, meaning simply I want the equation of the straight line that is touching the graph at x is equals to 1. When I'm saying at x is equals to 1, I'm indicating to you that the point has an x value of 1. How do I get the y value for that point? I substitute into the formula here, the original formula, so that I can get the y value. You see, one thing you must understand in functions in general is that if I know x, I can get y. and then if I know y, I can get x. That is how it works there. Understand? So here I know x, that x is 1. I can substitute x as 1 here, then I'll be able to get the y value. And to do it, I'll simply say f of 1 is equals to 2 into 1 cubed minus 1 plus 6. Guys, what is the answer that I get? I get 7. So therefore the coordinate is 1:7. And I'm substituting this into the original into the equation of f, not here. I do not substitute here. No. Why can't we substitute there? Because if we substitute here, we are not going to be finding a y value, but we're going to be finding a gradient if we substitute into this equation. That equation, you only use it to find a gradient, not the y value. So this one is the one that you use to calculate the y value, as you saw me do. Okay, but now I'm faced with a challenge. I only know 1 point on this straight line. Remember, to find a gradient I need 2 points, so that I can say m is equals to y2 minus y1 all over x2 minus x1. But the problem is I have only 1 point. So that is where, guys, we don't need to worry. You just find the derivative. As we found it, this is our derivative. Then we use it to find the gradient of this tangent at x is equals to 1 at that point there. So how do we use it? Now remember that f prime of x is equal to 6x squared minus 1. If I want to know what is the gradient at x is equals to 1, I substitute here. The gradient at 1 is going to be 6 into 1 squared minus 1. So it's going to be 6 minus 1, and the answer is going to be 5. So therefore it means the gradient of the tangent is going to be 5. It means here the gradient of this tangent is 5. Then that is the one I substitute here. I now say therefore y is gonna be 5x plus c. Now how can I get c? It's easy to get c now because I substitute the point there. Y is 7 and then x is 1. You see? Then I get 7 minus 5 is my c. Therefore c is equals to 2. So the equation of that is going to be y equals to 5x plus 2. Then I know this is the equation of the tangent. Y is equals to 5x plus 2. So please, guys, this is how we use it. What if I wanted to know the equation of the tangent that is passing through here? What if I wanted to find the equation of this tangent? What is the first thing I'll need to know? I'll need to know the x. So I tell you that here x is 5. Then you can substitute into the equation here. To get the y value, you need this coordinate. You know that x is 5, but you don't know y. So you substitute into the original equation. Say 2 into 5 cubed minus 5. Right, I'm substituting here on x. And then I say plus 6. So 2 into 5 cubed minus 5 plus 6. So the answer that I get is 251. If it's 251, it means the point there I drew it in the wrong place. It should be, this tangent maybe should be at the top there. Maybe here. Somewhere around here. Okay, so still x is 5. Right. Yeah, then the y value is 251. What a very big y value. Then I use it now to find the equation of the tangent here. This is a tangent. I want its equation. So I simply say y equals to mx plus c. But I don't know the gradient. So for me to get the gradient, I need to find substitute this x value into the equation of the derivative to get the gradient. So I'm gonna say f prime of 5 is equal to, then I substitute here, 6 into 5 squared minus 1. So you say 6 into 5 squared minus 1, so the answer is 149. That 149 is the gradient at that point, is the gradient of the tangent. So therefore I can now say y is going to be equal to 149x plus c. Then how do I get c, guys? I simply substitute the point. So I say 251 is my y value, and then what is my x value there? It's 5. Then I can solve for c. So I'll say 251 minus 149 times 5. So I'll get negative 494 as my c. So therefore the equation of the tangent is 149x minus 494. Not quite difficult there. The main thing that I wanted you to get here, that I want you to understand here, is that the derivative of the function gives you an equation which that equation you use it to get the gradient at any point that you wish for. Right, now let's look at some of the previous papers, guys, in terms of what they say regarding that. I'm hoping we can find something quite interesting here on November 2016. Oh, I don't see. Wait. Okay, if you can just give me a second, I'll find it now. Aha, let me show you here. Let me show you some of the complex questions that can come only from that knowledge. Here's a 5-mark question here, and then understand what they are saying. They're saying to you g of x is equals to minus 8x plus 20 is a tangent to that. Calculate the value of a and b. Right, quite an interesting question, and it's built upon what we just learned. So guys, in calculus, most of the times you need to understand what you are given. Okay, you need to greatly understand what you are given. So let's start. This is given to be a what? It's a tangent. Before I go anywhere else, since that thing there is a tangent, what am I gonna do? Well, it's simple. I have to understand that a tangent is a line. Guys, usually when you sketch, you are making your life very, very easy. The sketch doesn't have to be accurate, but it's gonna make your life easy. Remember, this is given as f. This means this is the graph. The highest exponent here is 3. It means you are dealing with a cubic function. So if I were to draw f, right, I can say I have a tangent. I don't know where it is, so I'm just gonna put the tangent here. Here's the tangent. Guys, a tangent, remember, is simply a straight line. So its equation is defined by y is equals to mx plus c. Well, what do you know? They already gave me the equation of the tangent, right? Because they said g of x is a tangent. So that means the equation of this tangent is already y is equals to so let me write here tangent. It's g of x is equals to negative 8x plus 20. This is the equation of the tangent. You understand? Is the equation of that tangent. Since it's the equation of a tangent, till now we know that a tangent is y is equals to mx plus c. Then what does this mean? This means g of x is your y. You can actually write this as y is equals to negative 8x plus 20. So if you look at this formula that we originally know, we can find out what we are given there. What are you given? This means you are given that the gradient of the tangent, the gradient of your tangent is equal to -8. That's the first thing we're given. And then we know our C would be 20. You see, you're already given the gradient of the tangent. Nay, that is the first thing there. You're given the gradient of the tangent. And you will see how it helps us in a few minutes. So, now that we know the gradient of the tangent and we know C, we're given f. This is our f of x. And our f of x is given as x cubed plus ax squared plus bx plus 18 at x is equals to 1. So, what do we know here? If they give us x is equals to 1, do you remember I told you that if you have x, you can get y? So they gave you x, you can get y. Where is this x is equals to 1? If you look at here, the x is equals to 1 is here. You don't have the y value, because that's where the tangent is. You understand? That's your point of tangency. So you need to get the y value. Now the question is, how do we get the y value? How do we get the y value? Where do we substitute? Into the derivative or into the function, the original function? Yes, into the original function. So you are gonna say f of 1 is equals to 1 cubed plus a, you don't have a, but you say 1 squared plus b 1 and then plus 18. This is b, guys, it's not 6. So your f of 1 is gonna be 1 plus, guys, 1 squared is just 1. 1 times a is simply a, and then you have b there, and then you have plus 18. So f of 1 is gonna be equal to a plus b plus 19. Now, guys, you see that? Do you see that you were stuck? Because I don't know A, I don't know B. Ne? I don't know A, and then I do not know B. So that means that I'm stuck. I can't find the y value. This is why calculus, most people, then they feel like it's difficult, because it will have so many unvariables that you do not know. But you don't need to panic. You don't need to panic. Do you know why you don't need to panic? This is because I'm already also now teaching you functions. This is because quadratic formula. We can use the quadratic formula there, say. We can use the quadratic formula, because when do you use the quadratic formula? That's mostly when you're looking for the intercept, and that's in parabola there. So here we can use the quadratic formula because we don't have an equation equal to 0. To apply quadratic formula, you must have something is equal to 0. But check, say, remember the end goal is to get the y value here, and I don't have a, I don't have b. So now I can't find the y value. If I knew them, a and b, then I would simply get the answer here. That would be my y value here. But I don't have a and b. Now I must try other alternatives. Guys, let's understand the following. This point is special. It's called boy. I usually call it boy. To say Ntwana, Vuga, understand the following. This is called a point of intersection. And graphs, when you're dealing with functions, you are going to have point of intersection a lot. It's called the point of intersection. What is a point of intersection? This is a point whereby two graphs meet or cross each other. So a point of intersection means this point belongs to the tangent, and at the same time that point belongs to the bigger graph. You must not think that the point of intersection just means that it belongs to one graph. The point of intersection means that it's a point that belongs to both the graphs, the graph of the tangent and the graph of the cubic function. Are we clear? That is a point of intersection, and that you will find it even a parabola can cross an exponential. It's a point of intersection. A straight line can cross a parabola. It's a point of intersection. That point belongs to both graphs. Now, what I mean by that, or how does it help us? It's gonna help us, guys, because we already have the formula for the tangent, right? We already have the equation for the tangent. Remember that it is this one. Since this point does not only belong to the cubic, I can substitute the point on the tangent. You understand? So I would say, I can say g of 1 is equals to negative 8 into 1 plus 20. So that means I'm going to have negative 8 plus 20. So my answer is going to be what? 12. That is g of 1. Good people, that means that when your x is 1, the y value is 12. I repeat again, when your x is 1, your y value is 12. It means here you have 12. So please understand that that point, it belongs to the bigger function. It also belongs to the tangent. Well, what do you know? So that means, yes, you can ask Mr. Rowan. Okay, as he's preparing his question there. So guys, if I already know that here y value is that, remember this is your x value, this one is your y value. So that means here we already have the answer then, because f of 1 means the y value when x is 1 on the graph of f. That y value is going to be 12. A plus b plus 19. This 12, this point belongs to this function, and it also belongs to this function, since it's a point of intersection. So if I do this, guys, I will have a plus b plus 19 minus 12. So I'll have 0 is equals to a plus b, and then what is 19 minus 12? It's 7. But guys, I still don't have a, I still don't have b, so I have not answered the question. We're just trying to connect the dots. We have not answered the question. So now one of the other things we can do here is to find the derivative of f. If you derive f there, guys, who said because you don't have a and b you can't find the derivative? You can find the derivative there, and that is an important concept. It's quite an important concept. Okay, so if we find, how do we find the derivative of this one? Remember, you say 1 times 3, it's going to be 3, and then you say the exponent, which is 3, minus 1, the answer is 2. Take it this side. Let's keep going. A times 2. Guys, you're gonna say the coefficient times the exponent. You see, then you remove 1 from the exponent. So a times 2 is what? It's 2a. So you write 2a there. And then you say 2 minus 1. So x is gonna have exponent 1. Don't forget to write x. That is a common mistake that people do. And then here, the x has exponent 1, so you can simply take the coefficient as b. Do I have to take 18? Remember, the derivative of 18 is 0 because it's a constant. Are we clear? What is this thing? It's an equation that we use to find the gradient of a tangent at any x value. I repeat again, it's an equation that we use to find the gradient of the tangent at any x value. So the x value that we're dealing with is what? Is 1. That is the x value we're dealing with. So let's say we're gonna act you're gonna act as if you didn't know the gradient of the tangent at x is equals to 1. You act as if you don't know it, and you substitute x as 1 as if you want to calculate it. You say, okay, f prime of 1 is gonna be 3 into 1 squared plus 2a into 1 plus b. So you're gonna have f prime of 1 as being equal to, this thing is just gonna be 3, and then here you're simply gonna have 2a plus b. Good people, what are we doing here? We're saying this is the gradient of the tangent. This is the gradient of our tangent where at x is equals to 1. But my question now is, don't you have the gradient already of the tangent? You have it. So since we already have the gradient of the tangent, we know that this whole thing is gonna be equal to -8. Why? Because our gradient at x equals to 1 is -8. We were given in the question. And that's another thing about calculus. They give you things silently. They don't say them out loud. So now we can say, oh, okay. And guys, once you don't have a and b, you don't have a and b, then that means you're going to use simultaneous equations. You know that even in physics, that if I don't have acceleration and mass or what and what, I use simultaneous. So you can now say 0 is equals to 3 plus 8 is going to be 11 plus 2a plus b. So here I can make a the subject, guys, by saying minus b minus 7 and call it equation 1. Then this one, call it equation 2. Then now I can just substitute 1 in 2. So I'll put a here. I will say 0 is equals to 11 plus 2 into, my a is minus b minus 7 and then plus b. Just that my b is very ugly, so sorry for that. 2 times that is minus 2b, and then 2 times this one is minus 14, and then you have plus b name. So 11 minus 14, guys, is going to be 3, -3, and then you say minus 2 plus 1, it's minus b. So therefore b is simply going to be -3. Then you can now solve for a. So your a will be negative. Don't forget to put brackets and say -3 minus 7. So it will be 3 minus 7, which is minus 4. That is your a there. So guys, can you see how from just a simple concept of tangent and a function, we can develop a bit of a tricky question? What you just need to understand, guys, is that if you have a point of intersection, the point belongs to both graphs. And since we were given already the equation of the tangent, we can use that equation to find the y value for that point of intersection. And we found it. Then here, we acted. Guys, in calculus, you're always acting as if you don't know things. Here we acted as if you had calculated this already. Here you're gonna be acting like you don't know what is the y value. You see, then you are busy substituting 1. You substitute 1 and then you say, I'm stuck now, but I already know that the y value is what? Is 12. So I now put it here. Then I can get my equation. Similarly here, I act right as I don't know the gradient of the tangent at that x is equals to 1. I don't know what is the gradient of the tangent. Then I substitute 1 as if I want to get that gradient. But I already know that the gradient is what? The gradient is negative 8. Then I substitute it there. Then I have my other equation. That's how it works, guys. I'm hoping that we are together there. I hope that we are together. Let's see. Okay, then others is just derivative from, it's just differentiation rules, guys. You know, we need to know our differentiation rules. Do we have okay, yeah, but I hope we understand that, guys. Let me just also say, let's just say I give you maybe f of x is equals to 3x, no, maybe 2x cubed minus p x plus 6, then I say to you, the equation of a tangent is maybe k of x is equals to okay, maybe x minus 3 at x is equals to 2. Then I say find the value of p. So how you do that, guys? I said sketch, sketch f, and then understand that you have a certain tangent. Just draw it even anywhere. It's just for you to understand. So do we have the point of intersection? We only know that that point x is 2, and we don't know y. How can I get y? I try to substitute in here. I say f of 2 is equals to 2 into 2 cubed minus p into 2 plus 6. Then f of 2 is 8 times 2 is 16. 16 plus 6 is going to be 26. Let me just double check, yeah? It's late, we might make mistakes. 22 minus 2p. Now I find that I can't find the y value because I don't know p. I say okay, sharp, but I know this is a point of intersection, so it also belongs to this one. So I say k of 2 is equals to 2 minus 3, so therefore k of 2 is equals to minus 1. Then I know that here it's minus 1 now. So I know that f of 2 is minus 1, so I put as minus 1 here. Can I not solve for p, guys? I can simply solve for p. I'll say 2p is equals to 22 plus 1, meaning I took this to the side and took this to the other side. So therefore 2p is equals to 23. Therefore p is going to be 23 over 2. That's it. I'm hoping that we understand how it works, guys. And then if I didn't have two variables, I would find the derivative of this function, and then I substitute the gradient. The gradient here is 1. Okay, then I can be able to solve. So I hope that tangents are clear. Now, one of the things I want us to discuss before we depart is the graphs. Please, since we're already deriving there, let's go to the graphs. We need to know how to work with graphs. Now, for those ones, I have notes on the graphs. I'm gonna share the notes with you. Did I write them? Yeah. You have how many cases? You have 2 cases only for graphs. I want you guys to master graphs. Ne? So I'm gonna show you a method you can use to master any graph you're gonna be given in calculus. So the first one is gonna be this one. Let me just share with you here. These nodes, guys, I remember teaching them in class and asking these learners to say, write these notes. Because I myself, I was like, Ish, this is something that I know I would be using. Okay. In graphs, you have case number 1. Name. This is the interpretation part. Ne? Graphs, you need to know how to sketch them, but I'm showing you the interpretation part. If you want to know how to sketch the graphs, don't worry. The calculus playlist is going to show you how to sketch graphs, okay? Whereby I use, the what is that method? I use the synthetic method. Yeah, that's what it's called. So here I'm gonna show you how to interpret graphs. So the graphs for cubic functions, guys, they are like this. Y is equals to ax cubed plus bx squared plus cx plus d. Please note that d is your y-intercept all the time. D is your y-intercept. Okay? So that means your graph will always be 0 is to d. D is always the y-intercept. If your a is positive, your graph is going to increase, decrease, and then it's going to increase. But if your a is negative, your graph is going to decrease first and then increase and then decrease again. Okay, so understand that here it's increasing, here it's decreasing, and then here it's increasing, and then here it's decreasing, increasing, and then decreasing. I remember it was during those times whereby on TikTok there was this meme about crazes. When I'm asking them, is the graph increasing or decreasing? They're like, crazes. Yeah, it was just last year's meme. Quite interesting. So yeah, case number 1, guys. Case number 1. If you are given the full equation, ne latita. If you are given the full equation, meaning you know all the variables, jonga mama ngiti, you know a, you know b, you know c, or you just don't have like in the question they don't give you a, b unknowns, or but yeah, like was pure zonke. I'm trying it, but yeah, you are given, yonke is given to you. That is the first case. How do you deal with that case? It's quite simple. They're gonna be asking you to calculate coordinates of the turning point, or which are called the stationary points, right? And then how do you do that? If I ask you to calculate stationary points given that graph there, oh my goodness, let me let me write it here. If I ask you to calculate stationary points or your turning points there, the first thing you're gonna do is to find the derivative. So you say derivative is equal to 3 times 3 is 9, and then you have 3 minus 1 is 2. Negative 2 times 2 is 4, negative 4, and then you say 1. And then you say plus 1. This is the derivative. You remember that this derivative, we can use it to find the gradient of a tangent at any x value. So if you want maximum and minimum points, stationary points, local maximum, those are the ways they can use. You simply have to equate this to 0. You equate it to 0. After that, you simply solve for x. How do you solve for x? Like Mr. Rohan said, you use the quadratic formula. So that's when you're going to say x is minus b over, so it's minus 4 plus or minus b squared is negative 4 squared minus 4ac, which is 9, and then 1. That is 4ac, all divided by 2 into 9. So good people, if you do this, you'll be able to find the 2x values. So let's say we do it. Ne? You put it quickly in your calculator. Negative into negative 4. You say plus the square root of negative 4 squared, and then minus 4 into 9, and then 1. And then 2 into 9. What do you do? Yo, what did I do wrong? Oh, because I made this question up, it's not giving me, it's giving me maths error, which means it's just that question I just made it up there, ne? But please guys, you're gonna find 2x values there. Let's just say you find 2 and then you find 4. I'm just making an example. Like, when are you gonna find the values? How do you find the turning points? You simply substitute these values that you got, ne, into your equation, the original equation. So you say, remember the original equation is that one, the 3x cubed minus that. So you substitute f is equals to 2, you get the y value. You substitute f is equals to 4, you get the y value. So your coordinate will be 2 and that, and then 4 and that. Then guys, you would have found your turning points there, ne? The minimum and the maximum. Now how do you know which one is going to be minimum and maximum? You look at the value of a. If a is greater than 0, ne, then the point with the lowest x value is going to be the maximum, and then the next point is going to be the minimum. For example, let's say, now when we check this one here, which one will be minimum and maximum if a is greater than 0? Remember, this one starts first, 2, and then followed by 4. So it tells you that here is gonna be your maximum, and then here is gonna be your minimum. I repeat again, you check, ne? You check the value of a. The value of a will tell you that we start with a maximum and then we are going to a minimum. And then if a is less than 0, it will tell you that we are starting with a minimum and then a maximum. So a minimum and then a maximum. So since here you have 2 and 4, the smallest x value, the smaller x value is the one that starts, is the first point, and then the bigger x value is the second point. The smaller x value is the first point, and then the bigger x value is the second point. So if your a is positive, meaning if you have a graph like this whereby you have positive there and then maybe 2x and stuff, then you're gonna have a max and then a minimum. But if your a is negative, like maybe you have something like this, then you're gonna have a minimum and then you're gonna have a maximum. So the first point is gonna be your minimum, and then the second point is gonna be your maximum if a is less than 0, and then like that. Okay, so guys, that's how you find the turning point or the stationary point. How do you find the y-intercept? The y-intercept, guys, you say let x be 0, ne? So that means you're gonna say f of 0 is equals to 3 into 0 cubed minus 2 into 0 squared plus 0. So here you get 0. That means your y-intercept is simply 0 and 0. How do you get the x-intercept? So this one was the y-intercept. How do you get the x-intercept, guys? You let y be 0, ne? So that means you're simply gonna have 0 is equals to 3x cubed minus 2x squared plus x. Then you're gonna solve for x there. Okay, then that will be your y-intercept, your x-intercepts, I mean. How do you get point of inflection? To get point of inflection, you're gonna find the second derivative, ne? You're gonna find the second derivative, meaning you're gonna derive this equation again from here. So you find the second derivative. So now you're gonna say 9 times 2 is 18x, and then minus 4. Then guys, you equate that second derivative to 0, and then you solve for x. You divide by 18, you will get your x. That x is gonna be the x value of the point of inflection. So when after you get the x, make sure you substitute it into the original equation, to get the corresponding y value, because point of inflection means x and y. You must have the x and the y. So you substitute into the original equation and say f of 4 over 18. Then you will get the point of inflection. The point of inflection will help you to decide the concavity. Okay, will help you decide on the concavity there. Right, so that one is if you are not given if you know all the variables, guys. So these are quite simple questions if you are given the all the variables. I think I saw a question that was like that here. I wanted to make maybe an example of okay, not this one, but this one. Okay, but let's deal with the second case, guys, whereby you have some unknowns there. Whereby you have some unknowns. Now this one is gonna be quite a lot. So we just need to understand here, and then we'll be fine. Right, so I hope you know how to find turning points of a cubic function, y-intercept, x-intercept, point of inflection, and determining the concavity also. So now what we're gonna deal with is the following. What if you don't have some of the variables, right? Again, Miss Latita. What if you don't have some of the variables? Now these are going to be a bit difficult to see, guys, but look at it, digest it, understand it. There are 3 cases that you're gonna be faced with. This is like under case 2, you have like 3 branches. If you are given an equation and then you don't know A, you don't know B, you don't know C, or you don't know D, the first thing is to find the full equation and then answer questions about meaning those questions are going to ask you to find the full equation. After you find the full equation, now you can find above turning point, y-intercept, x-intercept, point of inflection and stuff. But what happens if you don't find the equation? The whole question, you are gone. You see, maybe not the whole of it, but you might just be gone there. So it's quite important. So guys, let me break it down for you. Case number 1, you can be given a turning point and any other point. For example, your graph is gonna be like this. And then they tell you that here you have 2 and 9, and then here they tell you that you have minus 3. Guys, this is giving you a turning point and then any other point. And if you have that, you can find the equation. That's the first case. And number 2, and sometimes they don't like to say things out loud. Like I told you, they might give you something like this. Yes, they gave you the turning point. But then you're gonna say to me, but Minir, I could not find the any other point that you're talking about. Guys, you must check. If it passes through the origin, they're already giving you the point 0 and 0. They just don't want to tell you. You see? So please, you must always check out for that. That is the first case. The second case, you can just be given the turning point only. Ne? You can just be given the turning point only. But okay, so in that case, that means you are given just the turning point. Guys, you can be able to solve this. Ne? And then we're gonna show you how. And then the last thing is that you can be given what, x-intercepts and then any other point. So maybe they might give you something like this: 3 negative 2 no 3 maybe 2, and then there maybe 0. There it's passing through the origin. Ne? So that means you are given x-intercepts. Then they might give you any other point, maybe this, maybe tell you this is 1, this is maybe 5, and no 3 over 2, let's say 2.5 and 6. You see, if you're given something like this is the third case. So guys, this is the first case, second case, and then this is the third case. Then I'm going to show you using previous papers that all of the questions you're going to find on graphs, they fall under these three. But you need to know how to approach them. So I'm going to send you another link. If you are still up, we can go through that and and look at a few problems, that we can use to practice that. So please remember those three cases. By the way, whereby they give you the turning point only, meaning on this second case here, they will give you turning point only, but they will give you the equation like with the A, B, C, and D. And they will give you maybe f of x as 3x. Maybe they might say x cubed plus b x squared, something like that. So as if you have the turning point only, you can still solve it. I have copied the link, and then I'm gonna just quickly send it to you guys. Please do join that one, and then we can proceed. Yeah, I sent you there. You can check it out, then we can proceed. And Mem has just sent me a question here. We're definitely gonna look at it. All right. Now that you've joined, we can proceed with that. Let's give you this calculus. Let's give you the whole of this calculus in terms of the graphs. Miss Portia has sent me a question. Thank you so much, ma'am. That seems to be a very beautiful question. I think I do have it. So we're gonna use it as an example. By just looking at it, guys, I was like, this is easy. Because once you understand this, you will see that you'll be unstoppable. It's NSC, it's SC 2024. Oh, I don't have that one. It's fine. I will project it here, ma'am, right? And then we're gonna look at it. Luena, you will see that this thing is just quite easy. Right. Now please note, ne? Please note that for this first one, you are gonna solve simultaneously at the end. Ne? There are high chances of that. And then for the second one, there are also high chances that you solve simultaneously at the end. Ne? Now, where do we start? Let me go through questions. Let me project a question, we categorize it, and then we apply the approach. Ne? So let me take a question, we categorize it, and then we apply the approach. That's what we're gonna be doing. Mem said 2024 senior certificate maths paper 1. Let me just get that paper because I don't have it. I do not have it for some reason. Oh yeah, I found it here. It was June 2024. Yeah, just to get a feel of what they asked there. Just got it. Let's see. Aha, very very nice question. Let me just project it there. So here's the question here, right? So yeah, here's the question here. Very very nice question. And by looking at it, guys, do you think it falls under category number 1, meaning this one, whereby you have a turning point and any other point, or turning point only, or intercept? It's either it's turning point and any other point, or turning point only, or x-intercept. So let's see. Where does it fall under? Can you just type it for me there? I would be really interested to hear your thoughts on it. Is it turning point only, or is it, because I get it, you have unknown values, so we're already dealing it as case 2. Case 1 is whereby you have everything, or you have turning point and any other point, or is it the intercept? Is it the x-intercept? Mr. Fatai already said it's the x-intercept. What are your thoughts, guys? Right, Mr. Spartley is also saying it's the intercept. Yeah, very nice, very nice. No, thank you so much for that, gentlemen. Indeed, it is the intercepts that we are given. It is the intercept when you look at it. Now, if it falls under the category of intercept, can we just take a moment and appreciate that actually we were correct there, that any question is gonna fall under these 3 categories. Yeah, we didn't miss. Now, how do we solve it now is the biggest challenge that we need to make sure that we look at. So what I would do is that I just want to project these steps here, maybe quite clearer compared to the one that I gave you there. That one was not visible. Yeah, so guys, here's what you do if you are given intercepts. This is the approach there that we use if you are dealing with x-intercept. Yeah, let's see if it's gonna work. Let me just close this other one because I need this to be. Now, if you are given x-intercepts, guys, you use that a into x minus x1, x minus x2, x minus 3. That's what you use. Ne? So you're gonna say, yeah, you're gonna say y is equals to a into ooh, your mic miss Portia. Okay, a into x minus x1, and then x minus x2, and then x minus x3. Right? That's what I said here, right? So the first part, check. So let's substitute the given intercepts. That is the second step, if we can check. Let's substitute the given x-intercepts. So now you're gonna substitute, what is the first x-intercept? You are given -1. I get. Hey, but check. You are given -1 and then you are given 5. How many x-intercepts is that? It's 2. But when you look at this one here, it has 3. Ne? So what I need you to do is that there is an x-intercept which is at the same time a turning point. You're gonna repeat it twice. I repeat again. There is an x-intercept which is also at the same time a turning point. Between E and G, which one is it? Please type it for me real quick. Between E and G, which one is the x-intercept which is the same time at the same time it's a turning point? It's E. Perfect. Perfect. So that means I'm gonna say x minus, make sure that you put brackets and you say -1. Then guys, you're gonna repeat it again. X minus, then you say -1, and then here you say x minus 5, which is the last one, the G there. Then you simplify inside there. You say y is equals to a into x plus 1, x plus 1, and then x minus 5. So you're gonna say y is equals to a into x. When you multiply these first two brackets, should we multiply? Okay, no, before you do that, after substituting, right, it doesn't, the next step, we have substituted the x-intercept. Now it says we must substitute the given points, any given point, because by right you must be given an x-intercept and any other point. You must be given the x-intercepts and any other point, so that you substitute that other point in there. But the question is here, when you look at it, do you have that other point? Yes or no? Can I hear in the comments, guys? Do you believe, or when you look at it, do you think you are given any other point apart from the x-intercept? Because that other point must be any other point apart from the x-intercepts given. Do we have any other point there? Mr. Spatle says yes. Which point is that? Can you tell me the point? Because when you look at it, it seems like you're only given the x-intercept, but we have another point given there. Exactly. Thank you so much, sir. The point that is given is 0 and -5. How do you know that is 0 and -5? Because remember, I told you that the last number there on the equation is the C. This is something that I mentioned when did I remove it somewhere? I think I can't find it anymore, but I told you that if you have y is equal into the equation of a cubic function is ax cubed plus bx squared plus cx plus d. Now I told you that the last number, which is your d, right? I told you that the last number, which is your d, is always the y-intercept. So you always have 0 is to d. So as you can see here, the y-intercept, the last number is -5, isn't it? So therefore this point is your y-intercept, and it is this point here, 0 and -5. That is your any other point there that you need. Now you need to substitute it into the equation, just like the step says there. So y is -5, and then your x is 0. You substitute 0 throughout, and then guys, you just put this in your calculator there. If you put it in your calculator, what should you get? It's like 1 times 1 and then times -5, so you simply get -5. Then when you divide by -5 there, therefore your a is gonna be 1. Very nice. We have already gotten the first one that our a is 1. Now we just need to find b and c. And to find b and c, guys, don't worry, the steps explain that after getting a, simply expand and simplify. You see, simply expand and simplify. So you're gonna say, therefore y is equals to, remember your a is 1, so you put 1 there, and then you say x plus 1, you say again x plus 1, and then you say x minus 5. Then you're gonna get x times x, x squared, x times 1, it's x, 1 times x is also x, 1 times 1 is 1, and then you have x minus 5. Then you're gonna get x squared plus 2x plus 1, x minus 5. Then guys, you simply, it's algebra now, Miss Latita. X times x squared is gonna be x cubed, and then x times 2x is gonna be 2x squared, and then x times 1 is going to be x. -5 times that is going to be -5 times that is going to be -5x squared. -5 times this is gonna be minus 10x. -5 times 1 is gonna be minus 5. So you're gonna have x cubed. 2 minus 5 is -3x squared. 1 minus 10 is -9, and then you have minus 5. This is your y. So guys, when you look at this, let me write it here. We have y is equals to x cubed minus, it's what, x cubed minus 3x squared minus 9x, I believe, minus 5. So now check, guys, remember this here is your a, this here is your b, this here is your c, this here is your d. And as you can see, you have answered the question. B is -3, C is -9, D was already -5. So you have filled in everything. You see, quite easy. Now here are some of the important notes I want you to know. If A is given, sometimes this A is gonna be given. Guys, that A can be given in this way. They will just write to you, f of x is equals to x cubed plus bx squared plus cx minus 5. If that A is given, then just substitute it here. There won't be any need of solving it. Then there won't be any need of giving you another point. You just substitute it in, and if one of the x-intercepts is also a turning point, then you use this, right? Just like we said that you repeat it. If one of the x-intercept is also a turning point, you just repeat it there. Yeah, that is it, that is it. That was quite easy and quick. Not just a bit of work, but yeah, if you can just follow that, you'll be fine. 9.2. Calculate the value of x for which f has a local minimum value. Now you see, they want to know the local minimum value, meaning your turning points, the x whereby, meaning the one this x here, because this is maximum, right? This is minimum. So they want to know which x value give us the minimum there. How do you find that? Already I told you when we started that when you find in turning points, you simply find derivative, then you solve for x. So that's what you're gonna do. You find the derivative and then you solve for x. So remember, this is f. So let me just do 9.2 here. Remember, your f of x is x cubed minus 3x squared minus 9x minus 5. Simply find the derivative there. Then you'll have 3x squared minus 6x minus 9. Then what do? You equate to 0 and solve for x. You can divide everything by 3, or you can just simply use your quadratic formula. Minus 2x minus 3 x 3 1 minus plus. So therefore your x will be negative 1 or your x will be 3. Remember, the smaller one is going to be this one here, negative 1. It's here on the maximum, and then the other one which is going to be here. So you have answered the question. X is equals to 3. 4 marks, easy 4 marks. Ne? And then use the graph to determine the values of x for which the second derivative times f is greater than 0. What is the second derivative, guys? Remember, I told you it is the point of inflection. So now you must just solve for the point of inflection there. Ne? So how do you solve for a point of inflection? Remember, we said you derive again. So that is 9.3. So you say the second derivative is gonna be no, wait. But we do need a point of inflection. We can't just solve this without a point of inflection. So we need to solve for it first. So we say 3 times 2, 6x, and then 2 minus 1 I get is 1. Then you say minus 6. Then you solve for x, guys, to get your point of inflection. Like I said, then you divide by 6 both sides. Therefore your x is 1. So that's your point of inflection here. X is equals to 1 is a point that is somewhere here. Guys, what is a point of inflection? X is equals to 1 is here, ne? This is the 1 here. But for you to find this point, you'll have 1 and then you need to find the y value. How do you get the y value, guys? Remember, I told you that you're gonna substitute into the original equation to get the y value. What is a point of inflection? This is whereby the graph changes concavity, ne? So when x is less than the point of inflection, ne? When x is less than the x value of the point of inflection, right? When x is less than that, the graph is going to be concave up. Is concave up. But when your x is greater than that x, the value at the point of inflection, then the graph is going to be concave. Oh, sorry, concave down here. And then here it's going to be concave up. What is concave up? Concave up is smiling. Concave down, it's sad. So this is concave down here. This is concave up. So the point whereby it changes the concavity, meaning being concave up and concave down to another concavity, that is the point of concavity. That is the point of inflection. So they want to know, and if we were to draw the graph, that graph, you should know that the point of inflection, you should know that it is a straight line. It is a straight line that is passing through here like this. This is your second derivative, guys. This one. Know that the first derivative of a cubic function is a parabola, and the second derivative is always a straight line. So the straight line is going to have the x-intercept at the point of inflection all the time. So they want to know, where is this sorry, and the graph of f, where are they both above the x-axis, meaning greater than 0? Where are they both above the x-axis? Here, or where they are both above or both below. So we can see that is from here, both of them are below here, so it is this answer here. And then where are they both of them above? From this point onwards, both of them are above. You see, that's where we want. So you'd simply say that for 9.3, x is less than your point of concavity, or x is greater than 5. For x is greater than 5, both of them will be above. Here, both of them will be below. Okay. So other than that, I hope that we understand how to get the equation and the likes. That was the first one. I so hope you can just send me, guys, any question you think that it's a fire question in terms of your guys, in that same paper, I found this question in that same paper, which is a nice question because we're just talking about it now. Oh guys, let me just open a new document. It's now a lot here. Yeah. Here's a question that I found there. The equation of a tangent to f at x is equals to 1 is given by this. Determine b and c. Very nice, So when you know that you are given x is equals to 1, this one is a parabola instead of a of a cubic. So it's a parabola that is like this as your f, and then you're gonna have a tangent here. Now x is equals to 1. This is 1. What is the y value? If I substitute f of 1, I'm gonna get 3 into 1 squared plus b into 1 plus c, and then you're gonna have 3 plus b plus c. Now I don't have b, so I can't solve there, and then I don't have c, so I can't solve. But then remember, the point of intersection belongs to both graphs, so you could find it using this one, isn't it? So if you use that one, you're gonna have y is equals to 9 into, what is the x? It's 1 minus 9. So the answer is gonna be 0. That means the y is 0 here. And since the y is 0, now you can substitute it here to say it's 0. 3 plus b plus c. And get it, that is the y value there. Then you say, by being given the equation, I know that the gradient of the tangent is 9 at this x value. So you quickly find the derivative of f. You say derivative of f will be 6x plus b. Remember, c is a constant, right? Then you say the derivative, you want the derivative where? You want the gradient at 1. So you say 6 into 1 plus b. But you can't get the gradient because you don't have what? You don't have b. Then you simply substitute the gradient that you have. That is 9. Then I can take 9 minus 6 will give me my b. So b is simply 3. Then I can now use that 3 here to solve for c. So therefore c is gonna be negative 6. So just something, just some snack. Sorry. Let me just get another question, guys, in terms of these graphs. Then I want us to apply those methods that I showed you there, guys. Those powerful methods there. Let's go to 2023. Let's go to 2023. 2023, they were so happy, Mus. Let me show you this one. They gave you the graph of f there. They want the coordinates of the guys, they gave you the graph, ne? They gave you everything about the graph, right? So if they gave you everything about the graph, then this falls under case 1, whereby everything is given. We just have to find turning points and stuff. You might even need to sketch it. Yeah, but so just speaking of the devil, they say determine the coordinates of the turning point. How do you find the turning point? Find the derivative. Ne? Find the derivative, then equate it to 0. Then you use quadratic formula. Then you find turning points. Sketch. Guys, I said sketching. I'm not going to be doing it now because it takes some time, but you can just, I'm going to send the videos for that. Use the graph to get k, for which that will have 3 real and unequal roots. Guys, this one is quite simple because you simply say your k must be between the maximum but greater than the minimum. So remember, once you get your intercept, your turning points, the y values are gonna give you the minimum and the maximum. Look at 8.4. The line G is a tangent to F at the point of inflection. Determine the equation of G. Ne? So I'm interested in that one. Here's the graph. Ne? They're telling you that at the point of inflection here, you have a tangent. Here's your tangent. Now your tangent there, we don't have its equation. We just know that it's g of x is equals to ax plus b. But for me to get the equation of the tangent, I need to get the gradient of the tangent. I need to get b by substituting a point, meaning this point. So first of all, I need to find the point. Ne? Well, I'm told that it's at the point of inflection. So it means I can find the point of inflection. Remember, by doing what? You say first derivative is going to be minus 3x squared plus 12x minus 9. Then you derive again. You say minus 6x plus 12. And then you equate to 0, guys. Remember, you equate to 0 to find the x value of the point of inflection. You say minus 12 is equals to minus 6x. You divide by minus 6. So your x will simply be 2. That means here x is 2. Now I need y. You see why it's important to always sketch? Now I need y. To get y, I substitute into the original equation. I say f of 2 is equals to minus 2 cubed plus 6 into 2 squared minus 9 into 2 plus 4. So now you can get the answer. Minus 2 cubed plus 6 into 2 squared minus 9 into 2 plus 4. So you get the answer is 2. So this means the y value there is 2. Guys, now I know I can get b easily by substituting this, but I need to get the gradient first. How do I know the gradient of the tangent at 2? I can find the equation that will give me the gradient at any point. Remember, it's the derivative. So I'm going to say the derivative at 2 is going to give me the gradient of the tangent at 2. So I say minus 3 into 2 squared plus 12 into 2 minus 9. So if you quickly put it into your calculator as minus 3 into 2 squared plus 12 into 2 minus 9, you get the answer as 3, which means the gradient of the tangent is 3. Then guys, you already have A now. So now you can say g of x is equals to 3x plus b. Then how do you get b? You substitute this point. 2 is equals to 3 into 2 plus b. Therefore 2 minus 6, b is minus 4. Then you are done. 6 marks, easy 6 marks. So please guys, especially those type of questions, I would feel sad if you just get them wrong, because these graphs are quite easy. Miss Latita, I hope that we are getting these. Let's go to this one. Where is it? Guys, most of these ones you're already given. I'm trying to find one whereby you're not given and you're trying to solve something there. If you have, guys, please send to me now. I would like to see those. Yeah, you're already given there. I'm not finding questions, guys. Let's check 2015. Maybe we might have something 2015. Here's a question here. Right, here's a question here. Let's try this one. Let's try this one. Right, let's try this one. Here's a question here. Now, from this question, I want you to tell me whether it falls under you are given a turning point and any other point, or you are given a turning point only, or you are given x-intercept and any other point. Please comment there, guys. I would like to know which this question do you think, which category do you think it falls under? Mr. Fatai says turning point. Right? Any other view? Any other? Miss Latita, you're not saying anything. Talk to me there. Miss Portia, talk to me. Which category does it fall under there? Mr. Rohan. Right. Turning point. Right, that's good. So indeed, it falls under the one for turning point, because you are told that P and Q are the turning points of H. Right? You just don't know P, but you know that Q is the turning point of H. And it's like you are given the turning point only there. So you're given the turning point only. You don't have any other point given. But this one, it's just a simple straight line. It's not a tangent. It's a simple straight line. So it's like you're given two functions, right? Now, let me pull up the instruction, the guideline. Obviously, I'm gonna send you these notes, guys, so that you understand, you apply them. Sorry. So, if you are dealing with a turning point, these are the approaches that you can take here. um you can substitute the given point into the original equation, okay, and then you call it equation 1. So you substitute the given point into the original equation and call it equation 1, ne? It's the same thing for this part, ne? In fact, they're just the same thing. I don't know why I repeated it. It's just the same thing, guys, ne? So let's see. H of x is equals to negative x cubed plus ax squared plus bx. Right, Mr. Clayton said I should substitute the turning point. This one is when you are substituting the turning point into the equation. This one you are substituting the given point into the equation and then the turning point into the equation. What a bad handwriting of mine. But then it's fine. The point is the point given, you must substitute. So we say substitute q, right? We substitute this point, we're gonna have 10 is equals to negative 2 cubed plus a into 2 squared plus b into 2, ne? Then I'm gonna have 10 minus 8 plus, guys, this is a, ne? 4a, and then you have 2b. Then now you can say 0 is equals to 18. Negative 18 plus 4a plus 2b. Guys, we call this equation 1, just like Mr. Clayton said. Now Mr. Clayton said you're gonna have to solve simultaneously there. So we don't have p. What's wrong with this question? We don't have p, and then we're just given g. This one is a funny question, how come we don't have let me see if they had a diagram, ne? Joe, there's no diagram. Guys, can we solve this thing? We don't have. Do we have any other point? Oh yeah, it's quite easy. Yeah. Do you see how we can do it, guys? Any suggestion there? Do you see how we can solve for a and b there? Wait. Oh yeah, yes. Do you see how we can tackle this thing? We have g of x, but we don't know that g is just given. Are they equal at some point? More. P and Q are the turning points. Oh yes. Do you see how we can solve that, guys? I mean, I've followed the guidelines that I gave you guys. Yes, the origin is also a point. Thank you so much. So they said it passes through the origin. That means you are also given a point. So it is actually this one. We have substituted. It's fine. Whichever order you're gonna follow, you just have to substitute the turning point. Then next you're gonna substitute the point, ne? So substituting the point will mean that, let me just write point here. We're gonna say 0 is equals to negative x. We put 0, right? Because y is 0 and x is 0. So we say 0 cubed plus a into 0 plus b into 0. Must everything give you 0 there? Yeah. Everything is gonna give you zero, miss. Yeah, no. Mm-mm. 2015, they were doing the most. Guys, did you also see that zero and zero is not helping us? Or did it help you there, guys? You found something? Yeah, no. Yeah, no, Mina, I didn't find anything. So if you found something there, guys, right? Tell me how you solved it, Mina. Che. Mm-mm. This one. Mm? This one. No, 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 no. Because we're not given there. Okay, but then it's fine. Um, I think there must have been an error on that question, guys. I con because there's no diagram and then that G there. We don't know what is happening with it, so we don't even know if G is crossing through P and stuff. No. So maybe okay. So maybe we can now shift focus to this one. Since we're saying turning point and any other point, we see that it doesn't work because that 0 and 0 is not working. Let's try to follow what we said here. You can substitute the turning point into the original equation, which is what we did. Ne? Then the next thing is to find the derivative. Let's try to find the derivative. Right, so if you find the derivative there, it's gonna be minus 3x squared plus 2ax plus b. And then once you have that, what do? You substitute the x of the turning point into your derivative. So the x of the turning point is 2, ne? So we say we substitute 2 there. We have negative 3 into 2 squared plus 2a into 2 and then plus b. Then we say 4, so we have negative 12 and then plus 4a and then you say plus b. But we know that what is the gradient of the tangent at 2? Since it's a turning point, the gradient of the tangent is going to be 0. So we say 0 is equals to negative 12 plus 4a plus b. Do you see that now we can solve simultaneously? Hey, yeah. Then now we can solve simultaneously there. Quite easy, ne? Yeah, but it seemed very difficult, but it's not. So you say 1 minus 2. So you're gonna be 0 minus 0, 0. 18 minus negative 12. Guys, remember you can always use substituting and stuff, you know. So I mean, I'm just using elimination. 4a minus 4a is 0. 2b minus b is b. So you're gonna have b. So negative 18 minus negative 12 is gonna be negative 6 plus b. Yo, now I can't see the difference between b and 6. So my b is gonna be 6. B is gonna be 6. So therefore, what do we get as a? So to get a, I would say 0 is equals to negative 12 plus 4a, and then I say now plus 6 because now I know b. So negative 12 plus 6, guys, is negative 6. 4a, then we'll have 6 is equals to 4a. You divide by 4 both sides. If you put it in your calculator, 6 over 4, the answer that you get is 3 over 2. Then you have proved that a is 3 over 2. and B is 6. Shoo, Mr. Fatai, that was a lot. That was a lot, wasn't it? But you know what, guys? If you go through this, if you just apply the methods I'm teaching you here, those graphs are gonna be a walk in the park in the exam. So what I just need you to remember is that if your graph you are given intercept and any other point, you know what to do. Use y is equals to a into x minus x1, x minus x2, x minus x3. Substitute the intercept you saw for a. But if your a is given already, just like here, you see a can be given in this form. They can just give you the equation like this. That means they will have given you that a is -1, you see. So you would substitute it there. Then if you're given a turning point and any other point, it's you substitute the given point, right? Then you substitute the turning point. Then you solve simultaneously. Ne? But if you're given only the turning point, just like in this case, we only had one turning point and we had to use it. So what we can do is to substitute the turning point into the original equation, have our first equation as you saw. Then you find the derivative and you substitute the turning point again, but then make sure that your turning point there is it's gonna be 0. The gradient there is gonna be 0, but you just take the x. That's why I said substitute the x of the turning point into the equation there, you see. And then after that you say equal to 0, then you can solve. All of the functions in calculus, they fall under those 3 categories and the first case. Good people, I hope that was clear. Thank you so much for joining me today, and a very, very good morning. See you guys. We'll meet again tomorrow.